Hello, and welcome to Mythos and Logos. 1,200 tons of stone, floating on wooden stakes in a swamp. Who thought this was a good idea? But that question pales beside this one. How did medieval cartographers draw accurate coastlines of a continent that wouldn't be officially discovered for another 300 years? A continent buried under ice for millions of years. A continent that supposedly no human eyes had seen unfrozen? Tonight, we will journey to Earth's most enigmatic landmass, a place where impossibilities stack upon each other like layers of ancient ice. We'll explore maps that shouldn't exist, discover forests that grew where now only ice endures, and stand at the threshold of mysteries that challenge our understanding of both geological time and human history. May I ask for your help? Liking and subscribing takes just a moment, but makes a huge difference for the channel. I'm grateful for your consideration. I'm also always amazed by our international reach, so I'd appreciate hearing where you're joining from and your local time. Feel time's current reversing, pulling you gently into an age when Antarctica held secrets now locked beneath 3 miles of ice, when perhaps this frozen desert bloomed with life, when maps drawn in Constantinople showed bays and islands that modern sonar has only recently confirmed exist beneath the glacial shield. Antarctica. The very word conjures images of endless white, of emperor penguins huddled against hurricane winds, of temperatures that would freeze your breath before it leaves your lungs. Yet this frozen fortress, larger than Europe, holds within its icy grip evidence of a radically different past. Not just different in the way climates naturally shift over millions of years, but different in ways that have sparked fierce debates among scientists, historians, and those who dare to imagine that our understanding of the past might be incomplete. Consider the sheer improbability of Antarctica's existence remaining hidden from human knowledge until 1820 AD. Every other landmass on Earth had been explored, inhabited, or at least glimpsed by humanity for thousands of years. Yet this massive continent, 14 million square kilometers of land, remained Earth's last true terra incognita. Or did it? Because here's where our mystery begins. Multiple maps from the 1500s and earlier show Antarctica's coastline with startling accuracy. Not the coastline as it appears today, shrouded in ice shelves and glaciers, but the actual rocky coastline that lies beneath, the coastline that hasn't been exposed to air for millennia. The Ottoman admiral Piri Reis drew his famous map in 1513 AD, claiming he compiled it from older source maps, some dating back to Alexander the Great. The Orontius Phineas map of 1531 AD shows Antarctica not only free of ice, but with mountain ranges and rivers flowing from the interior to the sea. The Bolsh map of 1737 AD depicts Antarctica as 2 separate landmasses, exactly as modern seismic surveys have revealed it to be, beneath the ice, a detail invisible to the naked eye and unknowable without advanced technology. How do we reconcile these impossibilities? How did ancient or medieval cartographers map a continent officially undiscovered, showing features confirmed only by 20th century ground-penetrating radar and seismic imaging? The comfortable explanation suggests these maps represent mythical southern lands, products of imagination rather than exploration. But the uncomfortable precision of their coastlines, the correlation with subglacial topography, the accurate positioning relative to South America and Africa, these details resist easy dismissal. Maps of the impossible. Picture a workshop in Constantinople, 1513 AD. The smell of ink and parchment fills the air, mixing with smoke from oil lamps that cast dancing shadows across scattered charts and celestial instruments. Admiral Piri Reis bends over his work table, carefully transcribing coastlines from ancient sources onto fresh gazelle skin. He works from charts captured in naval battles, maps purchased from mysterious traders, documents claimed to originate from the Library of Alexandria before its destruction. As his pen traces the western coast of Africa, it continues south, beyond the Cape of Good Hope, beyond Tierra del Fuego, outlining a coastline that curves east beneath South America. A coastline that shouldn't exist on any map for another 3 centuries. The Piri-Reis map presents our first great impossibility. Discovered in 1929 AD, during renovations of Istanbul's Topkapi Palace, this map fragment shows the Atlantic Ocean's western shores with remarkable accuracy for its time. But its southern portion ventures into the impossible. The map displays the coastline of Queen Maud Land in Antarctica, as it would appear without ice. Modern seismic soundings have confirmed that the subglacial topography matches the Piri-Reis coastline to an unsettling degree. Rivers are marked flowing from the interior to the ocean, suggesting not just an ice-free coast, but a temperate climate supporting flowing water. Even more puzzling, the map uses sophisticated mathematical projections. The Piri-Reis map appears to employ what we now call an azimuthal equidistant projection, centered near Cairo. This projection method supposedly wasn't developed until centuries later. How did a 16th century Ottoman admiral create or copy a map using mathematical concepts that wouldn't be formalized by European cartographers for generations? Move forward 18 years to 1531 AD. Orontius Phineus, a French mathematician and cartographer, publishes his world map, showing Antarctica in complete detail. Not partial coastlines or vague southern lands, but a fully realized continent with mountain ranges, rivers, and coastal features. The continent appears roughly centered on the South Pole, approximately correct in size, and positioned accurately relative to the tip of South America. Most mysteriously, the Ross Sea appears ice-free, with islands now known to exist beneath the Ross Ice Shelf clearly marked. The Phineus map shows Antarctica's interior, with river systems flowing from central mountains toward the coasts. If accurate, this would require Antarctica to have been mapped during a warm period when the interior could support flowing water. Geological evidence suggests the last time Antarctica's interior was warm enough for substantial river systems was at least 15 million years ago, long before any conceivable human presence, unless we're missing something fundamental about either Antarctic geology or human history. Critics argue these medieval maps represent theoretical southern continents, terra australis incognita, the unknown southern land that cartographers hypothesized must exist to balance the northern landmasses. Yet this explanation falters against the specific accuracies these maps display. Theoretical lands don't accidentally match actual subglacial topography. Imaginary coastlines don't correlate with seismic surveys conducted centuries later. Mythical rivers don't follow valleys that exist beneath miles of ice. The Bausch map of 1737 AD pushes the mystery further. Created by French geographer Philippe Bausch, this map shows Antarctica as 2 separate landmasses divided by a water channel. At the time, this seemed purely speculative. But modern research has revealed that Antarctica is indeed 2 distinct landmasses, East and West Antarctica, joined by ice, but separated by a rift valley that would be below sea level if the ice melted. Bausch claimed his map was based on ancient Greek sources. What Greek sources could have known Antarctica's fundamental geological structure? Then we have the Zeno map of 1380 AD, showing Greenland without ice, with mountains and rivers accurately positioned where they exist under today's ice sheet. The Haji Ahmed map of 1559 AD shows Antarctica and the Americas with impossible accuracy, including the land bridge between Alaska and Siberia that existed during the Ice Age but has been submerged for 12,000 years. Each map alone might be dismissed as coincidence or clever speculation. Together, they form a pattern that defies comfortable explanation. Professor Charles Hapgood of Keene State College spent years analysing these maps in the 1960s AD. His conclusion shocked the academic world. These maps appeared to be copies of copies, degraded through centuries of reproduction. of source maps created by an advanced maritime civilization during the last ice age or earlier. Einstein himself reviewed Hapgood's work, writing in the foreword to Hapgood's book that the idea of polar shift, which might explain some of these anomalies, deserved serious scientific consideration. The implications stagger the imagination. If these maps derive from ancient sources showing Antarctica ice-free, when were those sources created? The Antarctic ice sheet began forming 34 million years ago. Even during interglacial warm periods, only the coastal edges became ice-free. For Antarctica's interior, to support the river systems shown on these maps would require either a dramatically different understanding of geological time or the existence of an advanced civilization capable of mapping and recording geographic data millions of years ago. You stand at the edge of the world. You grip the ship's railing as another wave crashes against the hull, sending freezing spray across your face. The taste of salt mingles with something else, something ancient and clean, as if this water has never known pollution or human touch. The Southern Ocean churns beneath you in colours you've never seen water display before, deep purples and blacks, interrupted by foam so white it burns your eyes. You've been sailing south for 3 weeks, watching the sun's arc grow shallower each day, feeling the air grow sharp enough to cut, then you see it. At first, your mind refuses to process the sight. It appears as a line of light on the horizon, too bright, too solid to be clouds. As your ship pushes through the heaving seas, the line grows, rises, and reveals itself as a wall of ice, stretching from one end of the world to the other. The Ross Ice Shelf towers 200 feet above the water, though you know another 1,000 feet lurks beneath the waves. The face of the shelf glows with internal light, blues and greens pulsing within the ice like trapped aurora. You hear it before you fully comprehend its size. A deep groaning, almost below human hearing, the sound of 1 billion tons of ice shifting, breathing, living. The smell changes as you approach. Gone is the rich, biological scent of the open ocean. The air near the ice shelf carries nothing but crystalline emptiness, so pure it makes your lungs ache. You watch icebergs the size of cathedrals drift past, each one carved by wind and wave into impossible sculptures. Some are topped with perfect spirals, others hollowed into blue caverns, where the water echoes with sounds like whale song. You realize these floating mountains broke from the shelf decades ago have been circling Antarctica in the circumpolar current, slowly melting, slowly revealing layers of ice, laid down when your ancestors hadn't yet discovered fire. Your hands grow numb on the railing despite your thick gloves. The cold here doesn't feel like winter cold back home. This is the cold of deep space, of absolute zero barely held at bay. Yet as you stand at this threshold between the living ocean and the frozen continent, you feel oddly warm inside. Not physical warmth, but the heat of standing before something infinitely larger than yourself, infinitely older, infinitely patient. Antarctica waits, as it has waited for millions of years. It holds secrets in its ice, memories of the planet's youth, evidence of worlds that existed before humanity's first breath. The captain calls for anchor. Here, at the edge of the ice, you'll transfer to smaller boats, then to sleds, beginning your journey across the frozen desert to the continent's interior. But for now, you simply stand and witness this boundary between worlds. Behind you, the ocean heaves with life. Seals surface to watch your ship with intelligent eyes. Petrels wheel overhead, and deep beneath, whales sing their ancient songs. Ahead, nothing moves except wind-sculpted snow. Nothing lives except what huddles in the few ice-free valleys. Nothing changes, except on timescales that dwarf human comprehension. You are standing at the edge of the world, at the border between Earth's present and its deep past, between the known and the eternally mysterious. The sleeping giant, Antarctica sleeps, but its sleep is not peaceful. Beneath its blanket of ice, the continent groans and shifts. Mountains strain against the weight above them, and lakes of liquid water hide in eternal darkness. This sleeping giant covers 40 million square kilometers, making it larger than Europe, larger than Australia, double the size of the United States. Yet for all its immensity, Antarctica remains the least understood landmass on Earth. Its true shape hidden beneath an ice sheet that averages 2 kilometers thick and reaches nearly 5 kilometers at its deepest points. Imagine the weight of that ice. 26.5 million cubic kilometers of frozen water pressing down with such force that it has deformed the continent itself, pushing the bedrock in some places a full kilometer below sea level. If all this ice melted, global sea levels would rise 60 meters, drowning every coastal city on Earth. But the ice doesn't melt. It flows, like a river of glass moving in slow motion. The ice sheet creeps from the high interior plateaus toward the coasts at speeds ranging from meters to kilometers per year, a plastic deformation that has been ongoing for millions of years. What lies beneath staggers comprehension. Ground-penetrating radar and seismic surveys have revealed an entire continent hidden under the ice, as complex and varied as any exposed landmass. Mountain ranges rival the Alps in height and extent. The Gambutsev Mountains stretch for 3,000 kilometers beneath the ice, their peaks buried under 3 kilometers of frozen weight. These mountains shouldn't exist according to conventional geological theory. They're located in the middle of the Antarctic plate, far from any tectonic boundaries where mountains typically form. Their presence suggests geological processes we don't fully understand. Valleys larger than the Grand Canyon snake through the subglacial landscape. The Bentley Subglacial Trench plunges 2.5 kilometers below sea level, the deepest point on Earth not covered by ocean. If the ice vanished tomorrow, this would become Earth's deepest lake, far exceeding Lake Baikal. These valleys and trenches follow patterns that speak of ancient rivers, suggesting Antarctica once possessed a drainage system that rivaled the Amazon in scope. The bedrock map of Antarctica reveals it's not one continent but two, possibly three distinct landmasses, welded together by ice. East Antarctica forms a vast plateau, geologically stable for over 500 million years. West Antarctica consists of a scattered archipelago of mountainous islands. Between them runs the Transantarctic mountain range, one of the world's longest mountain chains at 3,500 kilometers, mostly buried beneath ice and snow. These mountains contain exposed rock layers that tell the story of Antarctica's journey from tropical paradise to frozen wasteland. Perhaps most mysteriously, over 400 subglacial lakes exist beneath the ice sheet, liquid water persisting in the darkness under kilometers of frozen weight. Lake Vostok, the largest, stretches 250 kilometers long and 50 kilometers wide, comparable to Lake Ontario in surface area. The water in Lake Vostok has been isolated from Earth's surface for at least 15 million years, possibly far longer. The lake remains liquid due to geothermal heat from below and insulation from the ice above, maintaining a temperature around -3 degrees Celsius below freshwater's freezing point, but kept liquid by pressure and dissolved gases. The ice itself tells stories. Ice cores drilled from the Antarctic sheet provide a climate record stretching back 800,000 years. Each layer of ice preserves ancient atmosphere in tiny bubbles, allowing scientists to measure prehistoric levels of carbon dioxide, methane, and other gases. These cores reveal dramatic climate swings, ice ages, and warm periods, catastrophes and recoveries. But they also show that even during the warmest interglacial periods of the past million years, Antarctica remained largely frozen. To find a time when Antarctica was truly ice-free, we must reach much further back. Whispers from Gondwana. Listen carefully, and you can hear them, the whispers of Gondwana echoing through Antarctic stone. 200 million years ago, Antarctica wasn't isolated at the bottom of the world, but nestled warm and green in the heart of Earth's southern supercontinent. Picture forests of towering conifers where now only ice endures, rivers meandering through valleys now buried beneath glaciers, dinosaurs browsing on ferns where penguins now huddle against the cold. Gondwana, that vast assemblage of land that included South America, Africa, India, Australia, and Antarctica, began its slow dissolution 180 million years ago. But Antarctica didn't race to the South Pole. It lingered, maintaining connections with its sibling continents through bridges of land that allowed life to flow between them like blood through capillaries. Even as recently as 45 million years ago, Antarctica still touched South America through the Scotia Arc and maintained proximity to Australia. In the transantarctic mountains, exposed rock faces reveal fossilized tree trunks, still standing where they grew, now turned to stone, but maintaining their growth rings, their bark texture, even the scars where ancient insects bored into their wood. These weren't Arctic-adapted plants clinging to life in marginal conditions. These were tropical and temperate species. Glossopteris seed ferns with their tongue-shaped leaves, massive tree ferns creating cathedral forests, ancestors of modern monkey puzzle trees, reaching towards skies that knew no ice. The fossils speak of connections that span the southern hemisphere. Lystrosaurus, a pig-sized herbivorous reptile, left its bones in Antarctica, Africa, and India, proving these lands were once joined. Glossopteris seeds, too heavy to be wind dispersed across oceans, appear on all the southern continents. The distribution patterns make sense only if these lands were once united, their life forms mingling freely across what are now impossible distances, before the freeze. Descend through the layers of Antarctic rock, and you descend through deep time. Each stratum a chapter in an epic tale of transformation. The basement rocks speak of an age when Antarctica straddled the equator, when its stones were laid down in tropical seas teeming with life. Limestone layers filled with coral fossils testify to warm, shallow oceans. Sandstones preserve the ripple marks of ancient beaches, the footprints of creatures that walk shores now buried beneath miles of ice. Move upward through the geological column and watch Antarctica's slow journey south. The Devonian period, 400 million years ago, left us fossils of freshwater fish in what is now the transantarctic mountains. The Permian, 250 million years ago, painted Antarctica with vast forests of Glossopteris, their fossilized leaves so abundant in some rock layers that early explorers used them as fuel for their fires. These forests grew in high latitudes even then, experiencing months of darkness, yet they thrived in a greenhouse world where global temperatures were far warmer than today. The Triassic period brought the first dinosaurs to Antarctica. Cryolophosaurus, the frozen crested lizard, hunted across floodplains that would have looked more at home in modern India than at the South Pole. This 7-meter predator, discovered in 1991 AD, provides direct evidence that Antarctica supported complex terrestrial ecosystems well into the age of dinosaurs. Its bones were found alongside those of a large prosauropod, an early relative of the long-necked giants, as well as a pterosaur, one of the flying reptiles that ruled Mesozoic skies. But it's the Cretaceous period, 145 to 66 million years ago, that shows us Antarctica at its most vivid. The continent still connected to Australia and South America, forming part of a polar supercontinent that nonetheless supported lush ecosystems. Discoveries on James Ross Island and Seymour Island have revealed an Antarctica that would seem like fantasy to modern eyes. Evergreen forests of southern beech, conifers, and ferns created a canopy above an understory rich with mosses and smaller plants. These forests grew despite 3 months of total darkness each winter, adapting to the polar light cycle while maintaining year-round greenery. The fossils from this period read like a catalogue of the impossible. Plesiosaurs and mosasaurs hunted in the seas around Antarctica, these marine reptiles, some reaching 15 meters in length, required water temperatures that would have made the Antarctic Ocean more like the modern Mediterranean. On land, armored ankylosaurs browsed on low-growing plants, while small ornithopod dinosaurs darted through the underbrush. Primitive marsupials, the ancestors of modern opossums and kangaroos, scurried through the leaf litter. Birds filled the forests with songs we'll never hear, their fossil bones telling us only that they existed, not how they sounded in those ancient dawns. In 2011 AD, scientists announced the discovery of fossil palm trees in Antarctica, dated to 52 million years ago. Palm trees in Antarctica, these weren't wind-stunted, marginal plants barely surviving at the edge of their range. The fossils indicate robust, healthy palms, similar to those now growing in tropical and subtropical regions. For palms to thrive in Antarctica, even during the Eocene thermal maximum, winter temperatures couldn't have dropped below 10 degrees Celsius. The Antarctic coast was a paradise of warmth and life. The sediment cores tell us about the seas as well. 55 million years ago, the Antarctic Ocean maintained temperatures around 20 degrees Celsius, warm enough for comfortable swimming by human standards. Coral reefs fringed the Antarctic coast. Tropical fish swam, where now only the most specialized cold-adapted species can survive. The ocean floor accumulated the shells of warm-water plankton, creating chalk deposits similar to the white cliffs of Dover. Then, 34 million years ago, everything changed. The Great Cooling. 34 million years ago, Earth shuddered, not with earthquake or volcanic eruption, but with a transformation so profound it would reshape the planet's climate system forever. Antarctica, that green jewel at the bottom of the world, began its metamorphosis from paradise to prison of ice. The change didn't come in a day, or a year, or even a century. It unfolded across hundreds of thousands of years, a geological blink of an eye that nonetheless allowed some life to adapt, some to migrate, and most to perish beneath advancing glaciers. Picture the last day of warmth, somewhere along the Antarctic coast, perhaps in what is now the Ross Sea region. Morning sun filters through mist, rising from a river delta. Southern beech trees, their leaves rustling in a breeze that carries the scent of flowers and damp earth, shelter communities of marsupials and birds. Insects buzz through the humid air. In shallow coastal waters, fish dart through kelp forests, while primitive dolphins surface to breathe. Nobody witnessing this scene could imagine that within a geological moment, ice 2 miles thick would bury every trace of this living landscape. The causes of the Great Cooling read like a conspiracy of cosmic and geological forces. The Drake Passage opened between South America and Antarctica, allowing the formation of the Antarctic Circumpolar Current. This river of ocean water, the largest current on Earth, began to flow uninterrupted around Antarctica, isolating it from warm waters flowing from the north. Like a moat of liquid ice, this current created a thermal barrier that exists to this day, keeping Antarctica locked in perpetual winter. Simultaneously, carbon dioxide levels in Earth's atmosphere plummeted. During the Eocene, atmospheric CO2 measured over 1,000 parts per million, creating a greenhouse world where crocodiles swam in the Arctic and palms grew in Antarctica. By the early Oligocene, CO2 had crashed to around 600 parts per million and continued falling. The reasons remain debated. Increased weathering of rocks consuming CO2, changes in ocean chemistry, the rise of the Himalayas, altering global weather patterns, or perhaps massive algae blooms, pulling carbon from the air and burying it in ocean sediments. The ice began in the mountains. High peaks that once collected rain now accumulated snow that didn't melt in summer. Year after year, winter's white blanket grew thicker, compressing into glacial ice that began its slow flow toward the valleys. Plants at high elevations died first, then those at middle elevations as growing seasons shortened and soils froze permanently. The tree line descended relentlessly, forcing forests to retreat toward the coasts. Animals faced an impossible choice: adapt, migrate, or die. Some Antarctic dinosaur descendants might have survived the asteroid impact 66 million years ago, only to face this new catastrophe 30 million years later. Marsupials that had thrived in Antarctic forests had potential escape routes to South America and Australia before those land bridges finally severed. But countless species unique to Antarctica evolved over millions of years of isolation, vanished forever as their habitat transformed from forest to tundra to ice desert. The advance of ice created a feedback loop that accelerated the cooling. White ice reflects sunlight back to space far more effectively than dark forest or ocean. As ice coverage expanded, less solar energy was absorbed, temperatures dropped further, more ice formed. This albedo effect turned Antarctica into a refrigeration engine that began to cool the entire planet. Ocean currents reorganized, weather patterns shifted, the Eocene greenhouse world was ending, replaced by the icehouse world we inhabit today. By 20 million years ago, the East Antarctic ice sheet had formed, the first permanent ice sheet in Antarctica for perhaps 200 million years. By 14 million years ago, the West Antarctic ice sheet joined its eastern sibling. The continent that had hosted dinosaurs and palm trees was now entombed in ice, its bedrock pressed below sea level, its mountains buried, its rivers frozen in their valleys. The transformation was complete. Or was it? Lakes, hidden in darkness, beneath 3,800 meters of solid ice, in perpetual darkness that has lasted 15 million years. Lake Vostok waits. This body of liquid water, impossible by any reasonable measure, stretches 250 kilometers beneath the East Antarctic ice sheet. The pressure here equals 400 times Earth's surface atmosphere. The temperature hovers at -3 degrees Celsius. No sunlight has touched these waters since before humanity's ancestors descended from the trees. Yet Vostok lives. Russian scientists at Vostok Station first suspected the lake's existence in the 1970s AD when they noticed strange radar reflections from deep beneath their base. The ice sheet here behaved oddly, flowing around some invisible obstacle, like a river around a submerged boulder. Seismic surveys revealed the truth. A vast lake of liquid water, insulated by the ice above, warmed by the earth below, persisting through millions of years of isolation. The water of Lake Vostok remains liquid through a delicate balance of forces. Pressure from the overlying ice lowers the freezing point. Geothermal heat from the bedrock provides gentle warming. The ice ceiling acts as a perfect insulator, trapping heat that would otherwise escape to space. Most remarkably, the lake appears to have circulation. The ice sheet moves slowly across the lake's surface, melting at one end where pressure increases, refreezing at the other where pressure decreases. This glacial conveyor belt may introduce tiny amounts of oxygen and nutrients into the lake, creating the possibility for life. In 2012 AD, Russian scientists finally penetrated Lake Vostok, drilling through nearly 4 kilometers of ice to sample water untouched for millions of years. What they found defied expectations. The water was not sterile. Genetic analysis revealed sequences from thousands of species of bacteria and other microorganisms. Some appeared similar to known species. Others were entirely unique, evolved in isolation for longer than the human species has existed. But Vostok is not alone. Over 400 subglacial lakes exist beneath Antarctica's ice sheet, an entire hidden drainage system of liquid water in the continent's darkness. Lake Whillans, smaller than Vostok but more accessible, was sampled in 2013 AD. Scientists found a thriving ecosystem of microorganisms living without sunlight, surviving on chemical energy from the rocks, processing minerals in ways that might mirror the earliest life on Earth, or potential life on ice-covered moons like Europa. Some of these lakes connect through subglacial rivers, water flowing in total darkness beneath kilometers of ice. The Recovery Lake system includes 3 lakes connected by channels, allowing water and potentially life to move between them. Lake Concordia sits beneath Dome Sea, where the oldest ice core ever retrieved revealed climate records stretching back 800,000 years. Lake Ellsworth, 3 kilometers beneath the West Antarctic ice sheet, has been isolated for at least 100,000 years, perhaps a million. Each lake represents a time capsule, a pocket of liquid preserved from an era when Antarctica was warm. The organisms in these lakes might be descendants of creatures that lived in surface waters before the ice came, evolved and adapted to darkness and pressure over millions of generations. They might hold clues to how life began on Earth, how it might exist elsewhere in the solar system, how it adapts to impossible conditions. The implications extend beyond biology. These lakes affect how the ice sheet moves, acting as lubrication that allows glaciers to flow faster toward the sea. They may contain sediment records far older than ice cores, preserving evidence of Antarctica's climate stretching back tens of millions of years. Some scientists speculate that catastrophic drainage of subglacial lakes could trigger rapid ice sheet collapse, contributing to past episodes of sudden sea level rise. Most mysteriously, some researchers have detected what appear to be large, magnetic anomalies associated with certain subglacial lakes. These anomalies remain unexplained. They could result from unusual mineral deposits, concentration of magnetic sediments, or something else entirely. The lakes beneath Antarctica's ice hide secrets we're only beginning to discover. The fossil hunter's dream. Dr. William Hammer knelt in the Transantarctic mountains, his breath-forming ice crystals that fell like tiny diamonds onto the rock face before him. It was December 1991 AD, the Antarctic summer, offering a balmy -20 degrees Celsius. For weeks, his team had been excavating in the Beardmore Glacier region, following a hunch that these exposed rocks might yield the first dinosaur fossils ever found in Antarctica. As his hammer and chisel worked to free a suspicious shape from the sandstone, he couldn't know he was about to uncover Cryolophosaurus, the frozen crested lizard, proof that dinosaurs once hunted across Antarctic valleys. The skull emerged first, its distinctive crest unlike anything seen in dinosaurs from other continents. This wasn't some primitive creature barely surviving at the world's end. Cryolophosaurus was a sophisticated predator, 7 meters long, with teeth designed for slicing flesh and legs built for pursuit. It lived during the early Jurassic, 190 million years ago, when Antarctica still formed part of Gondwana. The presence of such a large predator implied a complete ecosystem: herbivores to hunt, plants for the herbivores to eat, a food chain complex enough to support an apex predator. Near the Cryolophosaurus skeleton, Hammer's team found something equally remarkable: the remains of a prosauropod, a long-necked, herbivorous dinosaur, along with a pterosaur, one of the flying reptiles. They also discovered fossilized trees, some still standing upright, preserved exactly where they grew. These weren't stunted polar adaptations, but substantial trees, with growth rings showing steady, healthy development. The entire assemblage painted a picture of Antarctica as a land of rivers and forests, where dinosaurs thrived just as their relatives did on other continents. The search for Antarctic fossils reads like a treasure hunt conducted in Earth's most hostile environment. Every summer, small teams of scientists race against time and weather, knowing they have perhaps 8 weeks before conditions become unsurvivable. They scan exposed rock faces in the Transantarctic mountains, one of the few places where Antarctica's buried history breaks through the ice. Each fossil must be carefully extracted, protected from freeze-thaw cycles that could shatter it, transported by helicopter or snowmobile to base camps, then shipped to laboratories for analysis that might take years. Beneath 3 miles of ice, you descend through the borehole, your body compressed into impossible thinness, to slip through the 10-inch diameter shaft that penetrates Antarctica's ice sheet. The journey begins in blindingly white fern, loose snow barely compressed, where individual crystals still sparkle with trapped sunlight. Down 10 meters, 20, 50, and the fern becomes denser, air squeezed out, crystals fusing together. You've entered ice, laid down during the Industrial Revolution. You can see the darkness beginning, the soot from London's chimneys and Pittsburgh's steel mills trapped in what was once falling snow. Deeper, 100 meters, 200, the ice grows bluer, compressed until it seems to glow with internal light. You pass through the medieval warm period, when Vikings farmed Greenland and wine grapes grew in England. Then the Roman optimum, when North Africa was the empire's breadbasket. The ice tells these stories in the ratios of oxygen isotopes, in the concentration of methane, in microscopic pollen grains blown from continents that were warmer, wetter, different. At 500 meters, you enter the last ice age. The ice here formed when massive glaciers covered Canada and Scandinavia, when sea levels were 120 meters lower, when humans crossed land bridges, now drowned beneath the waves. You feel the cold intensify, not physically, for you're already impossibly cold, but historically. This ice remembers woolly mammoths and saber-toothed cats, remembers humans huddled in caves painting animals by firelight. 1 kilometer down, the pressure has transformed the ice into something alien. All air bubbles have been squeezed into clathrates, crystalline cages where gas molecules are trapped within the ice structure itself. The ice is so clear it seems like solid atmosphere. You're travelling through the Eemian interglacial 120,000 years ago, when hippos swam in the Thames and forests grew in what is now Siberian tundra. Earth was warmer than today, yet Antarctica remained frozen, 2 kilometers. The ice ages blur together, glacial, interglacial, glacial again, each cycle lasting roughly 100,000 years, controlled by subtle changes in Earth's orbit and tilt. The ice records these astronomical rhythms in exquisite detail. You see volcanic eruptions preserved as layers of ash, the Toba supervolcano that nearly drove humanity extinct, Tambora that caused the year without summer. Each catastrophe left its chemical signature in falling snow that became ice, that became history. 3 kilometers down, you enter deep time. This ice fell as snow before Homo sapiens evolved, before Neanderthals, before any creature we would recognize as human walked the earth. The ice here is 800,000 years old, the limit of our continuous climate record. Below this, the ice grows stranger. Pressure and heat from below cause the deepest ice to deform and flow. Layers fold and buckle. Time itself seems to bend. At the bottom, just above the bedrock, you find the impossible, liquid water, a thin film, mere millimeters thick, where the ice melts under pressure and geothermal heat. This water flows slowly, following the bedrock topography, eventually reaching the subglacial lakes. In this darkness, under pressure that would crush any surface life, microorganisms thrive. They've been here millions of years, processing minerals, living on chemical energy, inhabiting an environment more alien than some planets. You touch the bedrock, Antarctica's basement, rocks that have been buried since before the ice came. Some are volcanic, speaking of a time when Antarctica rifted from other continents. Others are sedimentary, laid down in seas or rivers when Antarctica was warm. All have been pressed down by the ice, the entire continent deformed by the weight above. When you place your palm against this rock, you're touching stones that last felt sunlight 34 million years ago. Mountains that shouldn't exist. In 1958 AD, Soviet researchers conducting seismic surveys across the East Antarctic ice sheet discovered something impossible, a mountain range the size of the Alps, buried beneath 3 kilometers of ice. The Gambutsev Mountains, named after Soviet geophysicist Grigory Gambutsev, stretch over 3,000 kilometers beneath the ice sheet's heart. Their peaks rise 3,000 meters above sea level, even after being pressed down by the overlying ice. These mountains shouldn't exist. Mountain ranges typically form where tectonic plates collide, pushing Earth's crust skyward. The Himalayas rose when India slammed into Asia. The Andes grew where ocean floor dives beneath South America. But the Gambetsevs sit in the middle of the ancient East Antarctic craton, a stable piece of continental crust that hasn't seen tectonic activity for 500 million years. By all geological logic, any mountains here should have eroded to nothing long ago. Recent expeditions using ice-penetrating radar have revealed the Gambetsevs in stunning detail. The mountains display sharp peaks and deep valleys, features that suggest geological youth. River valleys, carved into their flanks, indicate flowing water once drained these peaks. Most mysteriously, the mountain range appears to have been rejuvenated, lifted up again after partial erosion, as if Earth's crust here has been repeatedly pushed skyward by forces we don't understand. One theory suggests the Gambetsevs formed over 1 billion years ago during the assembly of the supercontinent Rodinia, then were somehow preserved beneath later sediments. When Antarctica rifted from other continents, the removal of surrounding landmasses might have caused the mountains to rise again, like a compressed spring released. But this doesn't fully explain their remarkable preservation or their sharp, alpine features that should have been worn smooth over hundreds of millions of years. The Gambetsevs played a crucial role in Antarctica's freezing. These mountains were likely where the first permanent ice formed 34 million years ago, their high peaks collecting snow that wouldn't melt in summer. From here, glaciers flowed outward, eventually merging into the vast ice sheet that now covers the continent. In a sense, these hidden mountains were the seed from which Antarctica's frozen transformation grew. Beneath the ice, the Gambetsevs create a landscape frozen in time. Pre-glacial valleys still contain sediments from ancient rivers. Some valleys appear to hold large lakes, liquid water persisting in basins beneath the mountains. The range affects ice flow patterns across thousands of kilometers, creating areas where the ice moves slowly and preserves extremely old layers, and other areas where faster flow brings deep ice to the surface. The Antarctic Sound. Listen. Beneath the howling katabatic winds that scour Antarctica's surface, beneath the crack and groan of carving glaciers, beneath even the deep thrumming of the ice sheet itself, there exists a sound almost below perception. It's the resonance of an entire continent under pressure, a note so low it can only be detected by seismometers, a planetary bass note that rises and falls with the tides. The Ross Ice Shelf, that floating platform of ice the size of France, sings with the wind. As air flows across snow dunes and crevasses, it creates harmonics like a massive organ pipe. Scientists have recorded these sounds, sped them up to human hearing range, revealing melodies that shift with wind speed and direction. Sometimes the ice shelf moans, sometimes it whistles, sometimes it produces chord progressions that wouldn't be out of place in an ambient music composition. Deep within the ice sheet, you would hear sounds no human ear has ever directly perceived. The crack of ice crystals, reforming under pressure, creates a continuous crackling, like an infinite bowl of rice cereal. Glaciers flowing over bedrock produce grinding sounds that translate through the ice as vibrations, turning the entire sheet into a transmission medium for acoustic energy. In the subglacial lakes, water moves in currents we can only imagine, perhaps creating sounds like underground rivers, perhaps silent as deep space. The seasonal rhythm of Antarctica creates its own acoustics. In summer, meltwater percolates through surface ice, creating temporary waterfalls that plunge into crevasses with roars that echo through blue corridors. In winter, the thermal contraction of ice creates booming sounds like thunder, ice quakes that can be heard kilometers away. The formation of sea ice produces its own symphony, the crystallization of seawater, creating tinkling sounds like wind chimes made of glass. Evidence in stone. The Piri Reis map was just the beginning. Across Antarctica, researchers have documented geological features that spark fierce debate. In the Prince Charles Mountains, perfectly rectangular blocks of stone lie scattered across ice-free valleys. Each block measures precisely, with 90-degree angles and flat surfaces that appear artificially carved. Mainstream geology attributes these to natural freeze-thaw, fracturing along perpendicular joint patterns. But some observers note the blocks' remarkable uniformity, their arrangement in what could be interpreted as collapsed structures, their similarity to worked stone found at prehistoric sites on other continents. In Queen Maud Land, satellite imagery has revealed what some interpret as a vast network of geometric patterns beneath the ice. These lines and angles stretch for hundreds of kilometers, intersecting at regular intervals, creating what appears to be a grid pattern far too regular for natural formation. Scientists explain these as stress fractures in the ice or bedrock geology, visible through the transparent ice sheet. Yet the patterns persist across different ice thicknesses and bedrock types, maintaining their geometric precision in ways that challenge conventional explanation. The Wilkes Land gravity anomaly presents perhaps the most intriguing mystery. In 2006 AD, NASA's GRACE satellites detected a massive gravitational anomaly in Wilkes Land, East Antarctica. The anomaly suggests a dense mass beneath the ice, roughly 300 kilometers in diameter. Initial explanations focused on a massive meteorite impact crater, which would make it one of the largest on Earth. But the gravity signature doesn't quite match typical impact structures. Some researchers propose it could be a volcanic complex. Others suggest possibilities that edge into speculation. Could this be evidence of large-scale artificial structures, now crushed beneath millions of years of ice? Near the Antarctic Peninsula, divers have photographed unusual formations on the sea floor. Rectangular blocks, some several meters across, line arrangements that suggest collapsed walls or foundations. The blocks are covered in marine growth, indicating great age, but their shapes seem too regular for natural processes. Similar structures appear in sonar scans of areas now covered by ice shelves, suggesting that whatever created these formations predates the current ice coverage. In the Ellsworth Mountains, exposed rock faces display what some interpret as artificial terracing. These step-like formations rise up mountainsides in regular intervals, each terrace roughly the same height, extending for kilometers along ridge lines. Geologists attribute these to natural erosion of sedimentary layers with different hardness, but the terraces' uniformity, their consistent angles, their resemblance to agricultural terracing found in the Andes and other mountain regions, fuel alternative interpretations. The Vostok magnetic anomaly adds another layer of mystery. Beneath Lake Vostok, magnetometers detect a powerful magnetic anomaly that doesn't match the surrounding geology. The anomaly covers an area roughly 60 by 75 kilometers, far too large for typical mineral deposits. Some scientists suggest it could be an unusual concentration of magnetic minerals in sediments. Others propose more exotic explanations. Could this be metal deposits from an ancient meteorite, or something else entirely? Ground-penetrating radar has revealed buried structures throughout Antarctica that defy easy explanation. Linear features that could be natural fault lines, or could be constructed channels. Circular formations that might be ancient volcanic calderas, or might be something else. Rectangular depressions that could be collapsed ice caves, or could be the remains of structures built when Antarctica was ice-free. None of these features prove artificial construction. Each has potential natural explanations, but taken together, they form a pattern that troubles conventional understanding. If Antarctica has been frozen for 34 million years, if humans evolved only 300,000 years ago, then these features must be natural. Yet their precision, their scale, their similarity to known artificial structures elsewhere keeps questions alive in the minds of those willing to consider alternatives. The Warm Period Chronicles. Antarctica hasn't been continuously frozen since the Great Cooling began. Evidence points to several periods when the ice retreated, when parts of the continent emerged from beneath their frozen shroud, when life briefly reclaimed the land. These warm intervals, some lasting millions of years, others mere thousands, complicate our understanding of Antarctica's history and raise questions about what might have lived or visited during these ice-free windows. The Middle Miocene, climatic optimum, 14 to 17 million years ago, saw global temperatures rise dramatically. In Antarctica, the ice sheets contracted. The dry valleys, now among Earth's coldest deserts, hosted lakes fringed with vegetation. Sediment cores from this period contain fossil diatoms, microscopic algae that require liquid water and sunlight. Pollen grains in the same sediments come from southern beech trees and other plants, indicating that at least coastal Antarctica supported forests during this warm interval. The Pliocene warm period, 3 to 5 million years ago, presents even more dramatic evidence of Antarctic melting. Sea levels were 25 meters higher than today, suggesting significant ice loss from both Antarctica and Greenland. Sediments from the Ross Sea contain fossils of mollusks that require water temperatures at least 5 degrees warmer than present. Most remarkably, fossil finds from the Maya Desert Formation include dolphins and whales of species that today inhabit temperate waters, proof that the Antarctic Ocean was dramatically warmer. During the Pliocene, parts of West Antarctica may have been completely ice-free. The discovery of 3-million-year-old marine diatoms in glacial ice near the Transantarctic Mountains suggests open ocean existed, where now there's only ice. If West Antarctica's ice sheet collapsed during the Pliocene, it would have created an open seaway between the Ross and Weddell Seas, fundamentally altering ocean circulation and regional climate. Even more recently, during the last interglacial period 125,000 years ago, evidence suggests parts of Antarctica experienced significant warming. Ice cores show a spike in methane that could indicate wetlands forming on exposed Antarctic land. Sea level reconstructions suggest Antarctic ice loss contributed several meters to higher ocean levels. While East Antarctica likely remained frozen, West Antarctica may have partially collapsed, exposing land that had been buried for millions of years. Echoes of green Antarctica. In the wind-carved valleys of the Transantarctic Mountains, where ice sublimates directly to vapor under the dry polar air, ancient secrets emerge from the stone. Here, in the Beardmore Glacier region, fossil wood weathers out of cliff faces. Trees that grew when Antarctica was green now turn to stone, but still showing their growth rings, their bark patterns, even the borings of insects that fed on them millions of years ago. These fossil forests tell stories of a different world. The trees didn't just survive in Antarctica, they thrived. Growth rings show consistent, strong growth year after year. Some fossil trunks measure over a meter in diameter, suggesting trees that stood 30 or 40 meters tall. These weren't stunted polar adaptations, but full forest giants, forming canopies that blocked the sun and created their own microclimates below. The diversity astounds. Fossil leaves preserve intricate vein patterns, allowing precise identification. Nothofagus, the southern beech that still grows in Chile and New Zealand. Araucaria, the monkey puzzle tree with its distinctive spiral branches. Podocarpus, the yellow woods with their berry-like cones. Fossil ferns display fronds identical to species now found in tropical cloud forests. Fossil mosses, lichens, and fungi speak of a complete forest ecosystem with every ecological niche filled. Most remarkably, these forests grew despite the polar night. Even when Antarctica was positioned roughly where it is now, these trees endured months of total darkness, followed by months of continuous sunlight. They evolved strategies we see hints of in modern polar plants, but taken to extremes we can barely imagine. Some appear to have been deciduous, dropping leaves for the dark months. Others seem to have been evergreen, but capable of shutting down photosynthesis entirely, entering a state of suspended animation until the sun returned. The last forests of Antarctica persisted far longer than previously thought. Pollen grains from drill cores suggest that even as ice sheets grew, pockets of vegetation survived in protected valleys or coastal areas. As recently as 14 million years ago, dwarf shrubs and mosses grew in areas now buried under kilometers of ice. These last plant communities would have been islands of green in a white desert, gradually shrinking, finally vanishing as the ice advanced. The polar shift theory. Professor Charles Hapgood sat in his office at Keene State College in 1958 AD, studying medieval maps that showed Antarctica's coastline centuries before its official discovery. The conventional explanation that these represented mythical southern continents drawn from imagination failed to satisfy him. The accuracy was too precise, the details too specific. Hapgood proposed something radical. Earth's crust could shift position relative to its rotational axis, moving entire continents from temperate zones to polar regions in geologically brief periods. This wasn't the discredited idea of pole reversal, where Earth's magnetic field flips. Hapgood proposed crustal displacement, where the entire lithosphere, Earth's rigid outer shell, could slide over the molten layers below, like the skin of an orange, rotating around the fruit. In this model, Antarctica might have been positioned much farther north, until a crustal displacement moved it to the South Pole, triggering its freeze. Albert Einstein, surprisingly, took Hapgood's ideas seriously. In his foreword to Hapgood's book Earth's Shifting Crust, Einstein wrote that the mechanism Hapgood proposed, while requiring further evidence, was worthy of scientific consideration. Einstein suggested that ice accumulation at the poles could create an asymmetric weight distribution on Earth's crust. Once this imbalance reached a critical point, the crust could shift suddenly, moving land masses thousands of kilometers in a matter of centuries or even decades. The implications were staggering. If crustal displacement occurred, Antarctica could have been ice-free and habitable far more recently than conventional geology suggests. The medieval maps showing ice-free coastlines might be copies of genuinely ancient charts created when Antarctica sat at more temperate latitudes. Civilizations could have existed on Antarctica before the shift, their remains now buried beneath miles of ice. Mainstream geology rejects crustal displacement. Plate tectonics, unknown in Hapgood's time, explains continental movement through the slow drift of tectonic plates over millions of years, not sudden shifts. The forces required to move the entire crust would shatter the lithosphere long before causing displacement. Ice sheet weight distribution, while significant, isn't sufficient to overcome the enormous friction holding the crust in place. Yet certain evidence remains troubling. The extinction of mammoths in Siberia, some found frozen with undigested temperate plants in their stomachs, suggests dramatic and rapid climate change. The alignment of ancient sites like Giza, Angkor Wat, and Easter Island along specific geodesic lines hints at ancient knowledge of global geography. The universality of flood myths across cultures could reflect memories of catastrophic changes caused by crustal displacement. Modern variations of the theory propose more modest shifts. Perhaps crustal displacement occurs in small increments, moving continents a few hundred kilometers over thousands of years. Perhaps regional shifts affect only portions of the crust. Perhaps the process is more complex than Hapgood imagined, involving interactions between Earth's rotation, lunar tides, and deep mantle convection. Admiral Byrd's Strange Journey. February 1947 AD. Admiral Richard Byrd, America's most celebrated polar explorer, leads Operation High Jump, the largest Antarctic expedition ever mounted. Officially, the mission aims to establish American sovereignty in Antarctica and test military equipment in extreme cold. 6,800 men, 13 ships, and 33 aircraft converge on the frozen continent. What happened next remains one of Antarctica's most debated mysteries. Byrd's private diary, allegedly discovered after his death, describes a flight beyond the South Pole into a temperate region free of ice. He writes of green valleys, rivers, and what appeared to be a mammoth-like creature grazing below his aircraft. Most extraordinarily, he claims to have encountered advanced aircraft that forced his plane to land, where beings speaking accented English warned him that humanity's nuclear weapons threatened the planet's future. The diary's authenticity remains disputed. No official record confirms this flight. Yet Operation High Jump ended abruptly, months ahead of schedule, with significant loss of personnel and equipment. Official reports cite dangerous ice conditions. Witnesses describe military encounters that don't appear in any declassified documents. Byrd himself, in a Chilean newspaper interview, warned that the United States should prepare defenses against hostile aircraft that could fly from pole to pole at incredible speeds. What did Byrd actually encounter? Skeptics dismiss the diary as fiction, noting anachronistic language and concepts that seem borrowed from science fiction of the era. They point out that a temperate region beyond the pole would require heat sources that satellite imagery has never detected. The mammoth sighting echoes too perfectly the frozen mammoth discoveries that fascinated the public in Byrd's time. Yet certain facts remain unexplained. Operation High Jump's sudden termination has never been satisfactorily explained. Crew members who participated have told consistent stories of seeing unusual aerial phenomena, disc-shaped craft that outmaneuvered their aircraft. Several aircraft were lost in circumstances that remain classified. The operation's photographic records, over 70,000 aerial photographs, remain partially classified 70 years later. Walking through ancient valleys, you step out of the ice cave into a valley that time forgot. The walls rise 2,000 meters on either side, black basalt streaked with veins of quartz that catch the endless Antarctic summer sun. No ice exists here, in this parallel past, this vision of Antarctica before the freeze. The air smells of earth and growing things, alien after the sterile crystal purity of the ice sheet. Your boots sink slightly into soil, actual soil, dark and rich with organic matter that hasn't existed here for 15 million years. A stream runs through the valley's centre, its water black, with minerals dissolved from ancient rocks, too pure for any modern stream that must carry the pollutants of industrial civilization. You kneel and cup the water in your hands. It tastes of iron and stone, cold but not frozen, flowing from springs that emerge from deep aquifers that remember when rain fell here instead of snow. Along the stream's banks, southern beech trees spread their branches, their leaves rustling with sounds that haven't been heard on this continent since before humanity existed. You walk deeper into the valley and find evidence of the life that once thrived here. Fossilized logs lie where they fell, some still showing the scars of ancient fires that swept through these forests. In protected hollows, ferns grow in profusion, their fronds creating green curtains that filter the light into emerald patterns. You spot movement. A small marsupial, something like a opossum but different, evolved in isolation, scurries through the underbrush. Birds call from the canopy, their songs unlike anything in the modern world, melodies that developed in forests that no longer exist. The sun wheels around the sky, never setting during the Antarctic summer, creating a perpetual golden hour that bathes everything in warm light. You realize this is how Antarctica spent most of its existence, not as a frozen wasteland, but as a living landscape that happened to exist at high latitude. The polar location created unique conditions, months of darkness followed by months of light, but life adapted, thrived, created ecosystems as complex as any tropical rainforest. You climb to a ridge and look out across an Antarctica without ice. Rivers wind through valleys toward distant seas. Forests cover the lowlands, while alpine meadows carpet the heights. In the far distance, mountains rise without glaciers, their peaks bare rock painted red by the eternal sun. This view, impossible for 34 million years, feels more real than the ice-locked continent of the present. This is Antarctica's true face, the one it wore for hundreds of millions of years, the one it might wear again if the ice ever releases its grip. The magnetic anomalies. Beneath the ice of Wilkes Land, magnetometers scream with readings that make no sense. The magnetic field here spikes to intensities that shouldn't exist in continental crust, creating an anomaly visible from space, a magnetic mountain hidden beneath 3 kilometers of ice. Scientists have been measuring this anomaly since the 1970s AD, and every new survey adds to the mystery rather than solving it. The anomaly covers an area 300 kilometers across, far too large for any conventional mineral deposit. The magnetic intensity suggests either massive amounts of magnetite or other magnetic minerals concentrated beyond anything found elsewhere on Earth, or alternatively, artificial structures of a scale that challenges comprehension. Some researchers have proposed this could be the site of an ancient meteorite impact, the magnetic signature coming from shocked rocks or buried meteoritic material. But the pattern doesn't match known impact sites. Similar but smaller anomalies dot the Antarctic map. Near Lake Vostok, magnetic readings spike in patterns that follow no known geological features. In the Transantarctic Mountains, compass needles swing wildly in certain valleys, pointing to magnetic sources that remain hidden beneath ice and rock. Off the coast of Queen Maud Land, underwater magnetometers have detected linear magnetic features on the seafloor, straight lines that extend for hundreds of kilometers, maintaining consistent magnetic intensity in ways that natural formations rarely achieve. These anomalies affect more than just compass readings. They create corridors where cosmic rays are deflected differently, potentially affecting any life in subglacial lakes. They might influence the movement of charged particles in the upper atmosphere, contributing to the aurora australis patterns unique to Antarctica. Some researchers have suggested these magnetic fields could preserve organic material, or even DNA, in ways not seen elsewhere, creating natural time capsules in the ice. The source of these anomalies remains unknown. Every expedition that sets out to solve the mystery returns with more questions. Drill cores from above, the Wilkes Land anomaly, show normal crustal rocks with no unusual magnetic minerals. Seismic surveys reveal no massive ore bodies or unusual structures. The magnetic signature seems to come from deep beneath the bedrock, from sources our current technology cannot reach or perhaps cannot recognize. Modern expeditions revelations. The 21st century has transformed our understanding of Antarctica through technologies that would have seemed like magic to early explorers. Where Shackleton and Scott trudged across ice with sledges and desperate hope, modern scientists deploy satellites that peer through kilometers of ice, autonomous submarines that explore subglacial lakes, and drilling systems that extract cores of ice holding 800,000 years of climate history. Each year brings revelations that rewrite our understanding of the frozen continent and its deep past. In 2016 AD, researchers using ice-penetrating radar discovered a massive canyon system beneath the East Antarctic ice sheet. This canyon, larger than the Grand Canyon, stretches over 1,000 kilometers from the interior to the coast. It existed before the ice came, carved by rivers when Antarctica was warm. More remarkably, the canyon appears to still channel water, creating a subglacial river system that moves billions of liters of meltwater from the interior to the ocean. The discovery suggests Antarctica's plumbing is far more complex than imagined, with implications for how quickly the ice sheet might respond to warming. Satellite gravimetry has revealed that Antarctica is rising. As ice melts and flows to the sea, the reduced weight allows the compressed bedrock to rebound, lifting at rates up to 15 millimeters per year in some regions. This isostatic rebound tells us about the ice sheet's history, revealing where ice was thicker in the past. where it has thinned recently, where the continent is adjusting to changes that began thousands of years ago. The land remembers the weight it once carried and slowly returns to its original shape. Modern drilling projects have reached previously impossible depths. The European project for ice coring in Antarctica extracted ice from 3,200 meters depth at Dome Sea, capturing climate records stretching back 800,000 years. Chinese scientists at Dome A are attempting to reach ice over 1 million years old. Each core provides a timeline of Earth's climate, preserving ancient atmospheres in tiny bubbles, volcanic ash from eruptions that darkened prehistoric skies, even cosmic dust from meteor showers that fell when our ancestors were learning to use fire. But perhaps the most extraordinary revelations come from direct exploration of subglacial lakes. In 2013 AD, British scientists successfully sampled Lake Ellsworth, finding microbial life in water that had been isolated for hundreds of thousands of years. Russian scientists at Lake Vostok discovered over 3,000 species of organisms, most previously unknown to science. These discoveries suggest that beneath Antarctica's ice exists a biosphere as diverse as any rainforest, adapted to permanent darkness, crushing pressure, and near freezing temperatures. Remote-operated vehicles have mapped the underside of ice shelves, revealing inverted landscapes of channels, terraces, and caves carved by ocean currents. These submarine explorations have discovered ecosystems thriving in the dark waters beneath hundreds of meters of ice. Forests of sea anemones growing upside down on the ice ceiling, fish species found nowhere else on Earth, bacterial mats that carpet the seafloor in rainbow colours. Life hasn't just survived Antarctica's transformation, it has evolved to exploit every possible niche the frozen continent offers. The Climate Archive. Within the crystalline layers of Antarctica's ice sheet lies Earth's most complete climate archive, a record of atmospheric conditions stretching back nearly 1 million years, written in the language of isotopes and gas bubbles, readable by those who know how to decode its frozen script. Each snowflake that fell on Antarctica trapped a tiny sample of ancient atmosphere. Compressed into ice, these samples preserve the exact composition of prehistoric air. The carbon dioxide levels when dinosaurs walked the Earth, the methane spikes that marked massive releases from ocean depths, the oxygen ratios that reveal global temperatures from ages past. Scientists read this archive like a book written in ice. The ratio of oxygen 18 to oxygen 16 in water molecules tells them about ancient temperatures. Heavier isotopes condense more readily in cold conditions, creating a thermometer that spans geological time. Deuterium, heavy hydrogen, provides another temperature proxy, allowing researchers to cross-check their readings. Together, these isotopic signatures paint pictures of worlds dramatically different from our own. The ice remembers catastrophes. The Toba supervolcano eruption 74,000 years ago left a layer of ash visible in cores from across Antarctica. The Younger Dryas, that mysterious cold snap 12,000 years ago that plunged Earth back into Ice Age conditions just as it was warming, appears as a dramatic shift in isotopic ratios. The Medieval Warm Period, the Little Ice Age, the Roman Climate Optimum, all are written in the ice, their signatures clear to those who know how to read them. Most remarkably, the ice cores reveal the stunning speed at which climate can change. The end of the last ice age wasn't a gradual warming over millennia, but a series of abrupt shifts, some occurring in mere decades. Temperature swings of 10 degrees Celsius happened within human lifetimes. Sea levels rose in pulses, suggesting catastrophic collapses of ice sheets that released floods of meltwater. The Climate Archive shows Earth's weather system isn't the stable, predictable machine we once imagined, but a complex, chaotic system capable of sudden state changes. You feel the weight of time. You stand inside a cathedral of ice, walls glowing blue with filtered sunlight, that has travelled through 50 metres of frozen time. The cave formed where meltwater carved channels through the glacier, creating a space that seems designed by an artist who works in crystal and light. Every surface sparkles with frost feathers, delicate structures that grew overnight and will sublimate by evening. Temporary beauty in a landscape of permanent ice. You place your hand against the wall and feel the cold burn through your glove. This ice fell as snow when Rome was young, when the pyramids were already ancient, when writing was still a new invention. You can see the layers, each one a year of snowfall, compressed to a thin line. Thousands of lines, creating patterns like tree rings or geological strata. Dark bands mark volcanic winters. Clear bands speak of calm years, when snow fell pure and white. Together, they create a barcode of time that you could read if you had centuries to count. The silence here is absolute. Not the mere absence of sound, but a positive presence, a weight of quiet that presses against your eardrums. When you speak, your voice sounds strange, absorbed immediately by the ice, leaving no echo, no resonance. You realize this silence has persisted here for millennia, broken only by the occasional crack of settling ice, sounds no human has ever heard. Above you, through the translucent ceiling, you see shadows of things buried in the glacier, dark shapes that might be rocks carried from mountains hundreds of kilometers away, or might be something else. The ice here is moving, flowing toward the sea at speeds measured in meters per year, carrying its cargo of mysteries toward eventual revelation when the glacier carves into icebergs. What will emerge from the ice in coming decades? What secrets will melt free as the world warms? You breathe slowly, watching your exhalations crystallize instantly into tiny ice particles that drift like diamond dust through the shaft of sunlight. You are breathing out water that will join this glacier, will become part of this archive, will carry the isotopic signature of the 21st century into the deep future. Someone standing here in 1,000 years might analyze the ice you're creating and know something about the world you inhabited. The weight of time presses down through the ice above. Centuries, millennia, epochs. You stand at a moment balanced between deep past and deep future, in a place that existed before humans and will likely exist after, in an archive that records Earth's memories in the only medium stable enough to preserve them. Water frozen into crystal, time frozen into ice. What the ice remembers. Dr. Natasha Volkov held the ice core up to the light, watching bubbles trapped 50,000 years ago sparkle like tiny stars. This particular core, extracted from 3,000 meters depth near Dome Fuji, contained a mystery that had kept her team working through the Antarctic night. The ice here showed evidence of a warming spike, unlike anything in the surrounding layers. A brief period when temperatures rose dramatically, then fell just as quickly, all within the span of perhaps a century. The chemical signature was unprecedented. Methane levels spiked to concentrations that suggested massive releases from ocean depths. Carbon dioxide rose and fell in patterns that didn't match volcanic activity or any known natural cycle. Most puzzling, the ice contained microscopic particles of what appeared to be burnt organic material, as if vast fires had raged somewhere on Earth, sending their smoke to fall as black snow on Antarctica. This warm spike corresponded with no known geological event. It preceded the last glacial maximum, occurred during what should have been a stable cold period, and left no clear trace in other climate records. Yet here in the ice, preserved in crystalline perfection, was evidence that something extraordinary happened 50,000 years ago, something that briefly but dramatically altered Earth's climate system. As Volkov's team analysed the core, they found more anomalies. Pollen grains from plant species that shouldn't have existed at those latitudes, microscopic marine organisms typical of warm waters, dust particles with unusual mineral compositions that didn't match any known source regions. The ice remembered an event that conventional climate history had forgotten or never knew. The implications troubled established climate models. If such dramatic warming could occur naturally, rapidly, and leave so little trace outside the ice cores, what other climate surprises might Earth's system be capable of? The ice core suggested that our understanding of natural climate variability might be incomplete, that the system could change in ways we haven't anticipated or prepared for. The windless valleys. In the McMurdo Dry Valleys, Antarctica shows its face without makeup. Bedrock exposed to air for the first time in millions of years, a landscape so alien that NASA uses it to test Mars rovers. Here, in valleys carved by glaciers that retreated millions of years ago, less than 10 centimeters of precipitation falls each year, most of it sublimating before it touches ground. The air holds almost no moisture. The soil, if you can call it that, consists of weathered rock and volcanic ash, containing less organic material than the Sahara Desert. Yet even here, in Earth's closest approximation of Mars, life persists. In the summer, when temperatures might reach a balmy 0 degrees Celsius, cyanobacteria emerge from cryptobiosis, that state beyond sleep, where life pauses but doesn't end. These organisms live inside rocks, in the tiny spaces between crystals, creating a micro-greenhouse where they can photosynthesize during the brief summer. They've survived here for millions of years, perhaps descendants of organisms that lived when Antarctica was green, evolved to endure conditions that would destroy most life. The dry valleys hold other mysteries. Ventifacts, rocks carved by wind into shapes that seem deliberately sculpted, create gardens of natural art. Some formations appear almost architectural, perfect pyramids, precise spheres, structures that follow mathematical ratios. The wind here has had millions of years to work, uninterrupted by rain or vegetation, creating sculptures that blur the line between natural and artificial. Blood falls, stains the Taylor Glacier red, a flow of iron-rich brine that emerges from deep beneath the ice. This water has been isolated from the atmosphere for at least 2 million years. Yet it contains a thriving community of microorganisms that survive without oxygen or sunlight, metabolizing iron and sulfur in ways that might mirror early life on Earth or potential life on other worlds. The red cascade against white ice creates a wound in the landscape, as if Antarctica itself bleeds from some ancient injury. Lake Vida, covered by 20 meters of permanent ice, contains water 7 times saltier than the ocean, so saline it remains liquid at -13 degrees Celsius. When researchers drilled through the ice, they found the water teeming with life, bacteria that have been isolated for thousands of years, evolving in their own direction, creating unique biochemistries to survive in their liquid prison. These organisms might be Earth's best analogue for life that could exist in the subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus, guardians of the frozen past. Across Antarctica, research stations stand as lonely sentinels, tiny human outposts in an inhuman landscape. McMurdo Station, Antarctica's largest settlement, houses over 1,000 people in summer, creating a small town dedicated to science at the edge of the world. Here, researchers from dozens of nations work together, political boundaries meaningless in the face of Antarctic winter, sharing data and discoveries that belong to all humanity. At Concordia Station, sitting 3,000 meters high on the Antarctic plateau, scientists endure 9 months of isolation, 4 months of total darkness, temperatures that drop below -80 degrees Celsius. The air here is so thin that simply walking upstairs leaves newcomers gasping. Yet from this outpost, astronomers peer deeper into space than from almost anywhere on Earth, the dry, stable atmosphere providing views rivaling space telescopes. Glaciologists here drill into ice that fell as snow when our species was young. The Ice Cube Neutrino Observatory at the South Pole has transformed a cubic kilometre of ice into the world's largest particle detector, Thousands of optical sensors embedded in the ice watch for the faint flashes of light produced when neutrinos, ghost particles from across the universe, rarely interact with matter. This detector uses Antarctica itself as a scientific instrument, turning the continent into a telescope that looks not up but down through the entire Earth to observe the universe from below. Vostok Station holds the record for the coldest temperature ever measured on Earth, -89.2 degrees Celsius. Here, Russian scientists have maintained continuous observations for over 60 years, creating climate records that help calibrate global models. Their drilling project, reaching Lake Vostok after 20 years of effort, represents one of the most ambitious explorations of inner space ever attempted. At each station, scientists work as guardians of knowledge, extracting secrets from ice, rock, and sky. They've discovered that Antarctica affects global weather patterns more than previously imagined, that its ice sheets are more dynamic and vulnerable than once thought, that life exists in places that should be sterile. They've found meteorites preserved on ice fields, including rocks from Mars and the Moon. They've recorded sounds from the aurora australis, radio emissions that reveal the interaction between solar wind and Earth's magnetic field. These scattered outposts, supplied by aircraft that can only fly during summer, connected by satellite links that sometimes fail, represent humanity's determination to understand Earth's last frontier. The scientists who winter over, who spend months in darkness and isolation, who risk their lives in the planet's most hostile environment, do so to guard and decode the archives Antarctica has been keeping for millions of years. Dreams beneath the aurora australis dances overhead, curtains of green and red light rippling across stars, so brilliant they cast shadows on the ice. You lie on your back, insulated from the frozen ground, watching the southern lights perform their ancient ballet. The display tonight is particularly vivid. Solar particles from a coronal mass ejection 3 days ago, now colliding with Earth's magnetosphere, creating cascades of light that seem close enough to touch. The colours shift: emerald green from oxygen atoms 60 miles up, ruby red from oxygen at higher altitudes, rare blue from nitrogen, purple from a mixture of gases. The aurora makes sounds, or seems to, a crackling, hissing that might be real acoustic phenomena, or might be your brain trying to give sound to something so visually overwhelming. Indigenous peoples of the North reported hearing the aurora for centuries before science acknowledged the possibility. Between the aurora's ribbons, the southern sky reveals itself in its full glory. The Magellanic Clouds, 2 irregular galaxies visible only from the southern hemisphere, glow like cosmic fog. The Southern Cross points toward a pole star that doesn't exist, a dark patch where northern observers expect to find Polaris. The Milky Way arches overhead, so bright that it illuminates the ice field, billions of stars creating a river of light that seems to flow from horizon to horizon. In this moment, beneath lights that have danced over Antarctica since before life existed, you feel the continent's true isolation and connection simultaneously. Isolated at the bottom of the world, locked in ice, harbouring secrets that may never be fully revealed, yet connected to cosmos through the aurora, to Earth's past through its ice, to possible futures through the warnings its melting provides. Antarctica dreams, and its dreams are of timescales that dwarf human comprehension, of changes that unfold over millions of years, of secrets that sleep beneath miles of ice. Waiting, the eternal archive. Antarctica is memory made manifest, a continent that exists primarily as a record of what was rather than what is. In its ice lie the breaths of creatures extinct for millions of years. In its rocks hide fossils of forests that grew before flowers evolved. In its hidden lakes swim organisms that remember when the world was young. Every square metre of this frozen continent serves as a page in Earth's autobiography, written in a language of ice and stone that we're only beginning to translate. Consider what Antarctica knows that we've forgotten. It remembers the formation of Gondwana and its slow dissolution. It holds evidence of mass extinctions that reset life's trajectory. It preserves chemical signatures of asteroid impacts, supervolcano eruptions, and climate catastrophes that nearly ended Earth's experiment with complex life. Most remarkably, it remembers its own transformation from green paradise to white desert, a change so complete that finding evidence of Antarctica's living past requires drilling through miles of ice or searching wind-scoured valleys where ancient rocks lie. Exposed, the continent serves as more than a passive repository of information. Antarctica actively shapes Earth's present and future. Its ice sheet controls global sea levels. Its cold waters drive ocean circulation that regulates climate worldwide. Its white surface reflects solar energy that would otherwise warm the planet. The Southern Ocean that surrounds Antarctica absorbs more carbon dioxide than any other water body, while the circumpolar current that races around the continent affects weather patterns on every continent. What secrets still lie hidden beneath the ice? Satellite imagery reveals features we can't explain. Magnetic anomalies that defy conventional geology, buried landscapes that might preserve evidence of life forms we've never imagined. The subglacial lakes might harbour organisms that evolved in isolation for millions of years, creating biochemistries unique in the known universe. The bedrock might contain mineral deposits that formed under conditions that no longer exist on Earth. As our climate warms and Antarctica's ice begins its slow retreat, what will be revealed? Will we find only geological mysteries, evidence of natural processes we don't yet understand? Or will we discover something more profound? Evidence that Antarctica's history includes chapters we haven't imagined. The medieval maps that show Antarctica's coastline, the geometric patterns visible beneath the ice, the magnetic anomalies that suggest artificial structures. These mysteries await explanation. The indigenous peoples of the Southern Hemisphere have legends of a frozen land at the bottom of the world, stories that predate European discovery by centuries. The Maori speak of Huiteranjora, who sailed to a place of frozen seas in the 7th century AD. Aboriginal Australians tell of a time when their continent connected to lands further south, before the seas rose and the ice came. These oral histories, dismissed by Western science, might preserve memories of Antarctica from times when the ice was less extensive, when the continent's coasts were accessible to ancient navigators. Antarctica stands as Earth's ultimate archive, a library of deep time, written in a medium that preserves information for millions of years. It is a continent of questions more than answers, of mysteries that multiply with each discovery. As we develop new technologies to peer beneath the ice, to sample ancient lakes, to read the chemical signatures in ice cores with ever greater precision, we're not just exploring a continent, we're reading Earth's diary, discovering chapters of our planet's story that were thought lost forever. The frozen continent waits with infinite patience as humanity develops the tools and knowledge to understand its messages. It has waited 34 million years beneath its burden of ice. It can wait a little longer, but as the world warms and the ice begins to thin, Antarctica is beginning to reveal its secrets whether we're ready or not. The eternal archive is opening, page by page, discovery by discovery, mystery by mystery. In the end, Antarctica reminds us that Earth's history is far stranger, far more complex, and far more mysterious than we imagined. It tells us that continents can freeze, that paradises can become deserts, that life can persist in impossible places, that our planet's story includes chapters we haven't yet learned to read. Antarctica is proof that there are still wonders to discover, still mysteries to solve, still secrets sleeping beneath the ice, waiting for the right moment to wake. May these historical reflections have brought you comfort and calm. May the tranquil flow of time carry you to peaceful rest.